So our goal today is to review square roots, radicals, excuse me, as well as order of operations. So let's start by simplifying the radical. Can I take the square root of 64? It is 8. Whoop. So I'm done. So if that's a question on your test, please get it right. Square root of 28. Can you take square root of 28? No. So you look for a perfect square that divides evenly into 28. What's the perfect square that divides evenly into 28? Yes, 4. So I write square root of 4 and square root of 7. Because 4 times 7 is 28. Can you take square root of 4? Yes. And then you leave the root of 7. So that is simplified. This is not. I won't be telling you on the test, oh, you need to find 2 square roots. If it says simplify, you have to know what you need to do. So if you can ever take out a perfect square, you need to do that. C, there's a reason why this is not simplified. Do you know why this is not simplified? You cannot have a square root in the denominator. You can't have a square root of a number in the denominator. So we're going to rationalize the denominator because this is not a rational number. It's irrational. We need to make it rational. Maybe remember how we do that? We take that root of 6 and we multiply it by the top and the bottom. So I'll work it all out here. That's negative 5 roots of 6. Square root of 6 times the square root of 6 is the square root of 36. Can you take the square root of 36? And you will get 6. So it will always work out that the square root of the bottom times square root of the bottom will give you just that bottom number. Okay. Now this is simplified. Better? Okay. Addition and subtraction. I can't simply just subtract these two unless what number is the same? What numbers do I have to make the same? Yeah, the number underneath the radical here, this 27, this 48, those are called the radicands. The radicands must be the same. They're not. But maybe if I simplify them, then maybe they will be the same. So let's take this step by step. 2 times the square root of something times the square root of something. What is a perfect square that divides evenly into 27? What is a perfect square that divides evenly into 48? 4 and there's a bigger perfect square that divides evenly into 48. 16. There was a hint why I kind of knew it was 16. The 3. I mean, I want these to be the same eventually, don't I? So it's a good hint that they're going to come up to be the same. What's the square root of 9? Times 2. 6. So I have 6 roots of 3 minus square root of 16 times 4, 16 roots of 3. So see how nice that is that now they both have the same radicand. They both have the root of 3. So now I can subtract them. What is 16? Or I'm sorry, what is 6 minus 16? Negative 10 roots of 3. So that's simplified. So you can see we need to be able to simplify radicals, rationalize denominators, add and subtract. Let's continue to practice some of these. What's my operation here? Multiply. So let's just multiply them. I take the 3 times the negative 2 and I get square root of, and you can multiply these two radicals together. Square root of 5 times square root of 12 is square root of 60. But now we should ask if we can simplify it. Is there a perfect square that divides evenly into 60? 4. How many times does 4 go into 60? Think of your clock. 15. There's 4 15-minute segments in an hour, right? Okay. What is the square root of 4? Times negative 6. Good. You guys are smart. Requires some number sense, though, doesn't it? Yep. Okay, D, what should I do? Times by square root of 6. What is 6 times 20? 120. Over what? 6. Is there a perfect square that divides evenly into 120? 4 goes in how many times? 30. So we have the square root of 4 times the square root of 30 over 6. What's the square root of 4? So I have 2 times the square root of 30 over 6. Can that be simplified? Can 2/6 be simplified to what? 1/3. So it becomes 1 root of 30 over 3. So there's a 1 there that I don't write. Coming back to you a little bit. It's good to review it, right? I just assumed you remembered it all. Might not be so good. Square root of 44 plus 3 roots of 99. Ugh. Can I add them right now the way they are? I first must simplify. What's perfect square divides evenly into 44? 4 times 11. Very good. Plus 3 times. What's a perfect square divides evenly into 99? 9 and 11. Good. Square root of 4 gives me 2 roots of 11 plus square root of 9 is 3 times 3 is 9. 2 roots of 11 plus 9 roots of 11. It's kind of fun to write. Well, the last one before we do order of operations. Square root of 242. Can you think of a perfect square divides evenly into 242? Nope, 4 doesn't go in. Good try. One 121 is a perfect square. What times what is 121? 11 times 11. So, we have the square root of 121 times the square root of 2. Square root of 121 is 11. Somebody give me a 2-digit number. 50? 50 times 11. Right? Give me a 2-digit number. 979. Watch. I'll teach you. 43 times 11. Put the 4 here, put the 3 here. What's 4 plus 3? 473. How about 62 times 11? Put the 6 here, put the 2 there, add them together. We'll try a tough one. 87 times 11. Put the 8 here, put the 7 there, add them together. 8 plus 7 is 15. Got to carry the 1. 957. You thought 9s were the only great ones. 11s are great too. Okay. All right. Let's move on. Order of operations. What are the order of operations? please, or powers, parentheses, excuse me, exponents, multiplication, division, addition, and subtraction. Okay, so what do I do first here? 16 minus 10 divided by 2 plus 3. Got rid of my exponents. There were no parentheses. Now what? Yep. Now do I do the 5 plus the 3 first or 16 minus 5 first? Have to do 16 minus 5 first. Because it comes first, left to right. Now, there's always at least one in the crowd that says, my teacher once told me that addition comes before subtraction. If they did, they were wrong. So whichever comes first, left to right. So 16 minus 5 is 11, plus 3 is 14. There's different forms of grouping symbols. So you may say parentheses. Parentheses also include things like this. A radical is a form of grouping symbols. So we have 20 minus the square root of, what do I do first on the inside of the parentheses? Yeah, I do the 4 times the 5. So I have 5 plus 20. So I have 20 minus the square root of 25. Square root of 25 is? Answer is 15. You should always write something down for each step. What is my first step in letter C? Absolute values. What is 3 minus 6? And then the absolute value of negative 3 is, so we have 10 minus 3 over 8 minus 1. Now, you do have a grouping symbol here as well. This division sign separates the numerator from the denominator, so it is a grouping symbol as well. I get 7 divided by 7, which is 1. What if you have multiple sets of parentheses, like in D? What do I do there? Yep, I'm going to start on the inside. So 15 minus 8 plus 6 minus 2. So I was able to get rid of one of my parentheses sets. Now I go to this parentheses set. 15 minus 8 plus 4. Now I get to this parentheses set. 15 minus 12. You try E and F on your own. Are your answers 14 and 3? Good. Let's flip it over. 2 more problems, and then you can work on your assignment. Please try G and H on your own. A little bit more difficult. G and H. Oh, I just couldn't read it. came up with 16 and 1. Good to go there? This is still review, right? We've seen this. So we'll take 2 tests over material that's review. What we need to get through yet before we do our test, you can see we need to simplify order of operations. So we need to go through our exponents. We need to go through some factoring. We need to go through some equation solving. Those are things we still have to get through. So tomorrow and Wednesday is going to be a little bit more difficult, okay? Your assignment is a worksheet that I'll be handing out to you right now.